Yeah, so every linear system has either no solutions, one solution, or infinitely many solutions. In this case, the linear system is square size. The coefficient matrix is a square matrix. So if that coefficient matrix is invertible, then there's one solution, exactly one solution. But if it's not invertible, then it has to be one of the other two options. And this matrix is not invertible, and indeed, there is infinitely many solutions there. Does that make some sense? Okay, this seems like a good time to try the next problem on the sheet. Again, still working backwards. Number 3, which is problem 5 on my review sheet. Here's what it says. I give you x1 minus ax2 equals 3, and 2x1 plus x2 equals 6, and negative 3x1 plus a plus b x2 equals 1. You guys might remember I asked you a couple of homework problems like this. Basically, this is a linear system that has a few parameters in it that we don't know. And the question is just asking us, for what values of a and b will we have no solutions, one solution, or infinitely many solutions? So we're focusing on those 3 scenarios here. Okay, so to solve that question, to break down those cases, what am I going to need to do here? Exactly. I need to build my matrix, right? Build the matrix first. So my matrix is going to be 1, negative a, augmented with 3. Notice there's only 2 variables, x1 and x2. So I only have 2 columns here. And then 2 and 1 and 6. And then negative 3 and a plus b and 1. So there's my augmented matrix that goes with that system. And what I have to do is row reduce it, right? I'm going to do my EROs, so this is our chance to practice EROs. We're going to do it carefully, right? So the first, what ERO would you suggest I might want to do to get us started here? Addition with what and what?
1 and 2.
A 1 and 2 of what multiple? Negative 2, right? A 1, 2 of negative 2. That means I multiply the first row by negative 2, and I add the result to the second row. So I'll get 0 there. Negative 2 times negative a is 2a, and then plus 1. So 1 plus 2a, and then negative 2 times 3 added to 6 should be 0. All right? And can I do anything else at the same time? Okay, so a1 and 3 of what multiple? 3, good. So a1, 3 of 3, so I'm going to get a 0 again right here. And then when I multiply the first row by 3 and add to here, I'm going to get negative 2a plus b, I believe. And then when I do the same thing on the last entry, I'm going to get 10, I believe. That look okay so far? See, the whole idea here is you want this to be a pivot, so you do the appropriate EROs to make the entries below it come out to 0. They come out to 0 that way. We good with that? Okay. Well, what should I do next? I have to switch these two?
You could add them to get rid of the a.
I can add them to get rid of the a, but I'm not really getting rid of the a because
No.
I'm going to keep one of the 2 equations, right? You're not going to just replace. Yeah, this gets a little tricky. I guess what I would like to do is take the second row and divide it by 1 plus 2a in order to make a 1 right here in this position. Because that would become a pivot then, right? So let's do that. I'm gonna multiply row 2. So what am I gonna do here? I'm gonna multiply row 2 by what? 1 over 1 plus 2a, right? I'm just gonna basically multiply by that. So that's gonna give me 1 negative a augmented with 3, and then 0 and 1 and 0. and then 0 and negative 2a plus b and 10. Right? Now what I can do is I can choose a multiple of the second row to add to the third row. What multiple of the second row would I want to add to the third row? So, in other words, 2a minus b, right? The negative of that entry there, right? So I'm going to multiply the second row by 2a minus b and add that to the third row. Because what I want to do is make this into a 0. To make this into a 0, I've got to have its negative right here added to that. Matter?
Yeah, how would you know if 1 over 1 plus 2a is not 0?
Oh, I wondered if anybody was going to catch me on that. How do I know I'm not dividing by 0 right there? You're absolutely right. That is an issue. I'm going to come back to that. Let's assume right now that life is good in the sense that it's not 0 in the denominator. Okay? So as long as 1 plus 2a is not 0, everything I'm saying is perfect, right? Okay, so let's keep going. 1, negative a, augmented with 3, 0, 1, 0. These are my pivots. And now 0, 0, and 0, right? Oh, 10, sorry. 0, 0, and 10. Right. So what do we conclude at this point?
Inconsistent.
Pivot in the far right column means inconsistent, right? So no solutions. No solutions. Now, if you were not paying close attention, if we didn't have Nader here, or me here or something, somebody paying attention to realize that we did in fact divide by something here, we might think at this point that the only thing that ever happens with this system is that we always get no solutions. Because it looks like that's what happened, right? We took our linear system, we put it in a matrix, we row reduced it to something with no solutions. However, this no solutions only works as long as all of these steps were valid. And this step right here is only valid, so this is only valid if a does not equal negative a half. So as long as a does not equal negative half, as long as a does not equal negative a half, everything we wrote down is beautiful. And we get no solutions. Right? Okay. We therefore have to go back and consider that possibility. What if a did equal negative 1/2? Okay, so we need to, we're not quite done. We need to address that as well. You know what I find with these kinds of questions is that people usually know how to do the EROs and kind of break down the cases. It's just sort of writing down the conditions on the A and the B is a little tricky. So notice that the B is not even mentioned here. So regardless of what B is, as long as A is not negative half, there's no solutions. Okay? So you might be wondering, well, where's the B? Where does that come into? So let's go look at the other possibilities. So what if A does equal negative 1/2? What if A does equal negative 1/2? Here's what I suggest you do. If A is equal to negative a half, that means we're right here in this matrix. We can't go up to there because we'd be dividing by 0. So we're stuck here. But what I can do is I can actually put negative 1/2 in for A. If I'm assuming that that's what it equals now, if I'm in that case, I can plug that number in and see what I get, right? So then our matrix, our augmented matrix is, it's going to be the following thing, right? 1, negative A, augmented with 3, 0, 0, 0, right? I'm putting in negative 1/2 for A in the matrix on the bottom of that center board. And then 0, is it B plus 1? b plus 1, and 0. And now what I'm going to do, notice that, oh, I'm sorry, I should plug in what a is here.
And 10 at the bottom.
And 10 at the bottom. Keep trying to make that 0, sorry. And 10 at the bottom, and the a was negative a half, and we got negative of that, so it's 1/2. Sorry, guys. I've had a long day. I had to get up at like 6 o'clock this morning to read these applications. Okay, so we got that. And now we see there's no more a in there. That's because we plugged in the value. But now we see the b is here. Okay, so we can now keep working through it. Let's keep going. What I would do next, of course, would be to switch the all 0 row to the bottom, because we always do that. And then we'll have 0, b plus 1, and 10. So here's a pivot. Right? Now, is that a pivot? It could be, is the right answer, right? So if b plus 1 does not equal 0, if b plus 1 does not equal 0, then that's actually also a pivot. And if that was a pivot, then what would you conclude at this point? In terms of your 3 cases. One solution, right? You have no free variables, but you also don't have any pivots that made it into the far right column. So if b plus 1 is not equal to 0, exactly one solution. Now that's, in other words, b does not equal negative 1. But that's only if a does equal negative 1/2. In a minute I'll write down the summary of all the cases. Okay. On the other hand, if b plus 1 does equal 0, because you have to look at every scenario. I know. I probably won't give you something that's quite this complex in nature, but I don't mind doing it in a review. If b plus 1 does equal 0, well then, this is not a pivot anymore, and what do we conclude?
No solution.
No solutions.
We're back to no solutions again. The pivot would